So here's the point. We make this prediction or projection based on Moore's law. This is the history of computers over almost a century. And it projects to a capacity to equal our capability in robotic form in about 20 or 30 years. Depends how you do the projection. And of course, that could either be a computer that can do what we do, or a machine that can generate the ability to travel between stars and colonize the galaxy. Both of those possibilities are projected by our capability within a couple of decades. And the most important point is that we don't have to go there ourselves. We can send the machines instead of us. So a simple model of 10th light speed travel, you're not violating relativity, can have us colonizing the galaxies. And this colonization will be done by our progeny, and our progeny will be machines. It won't be us. We're too frail. We won't go. So let me just talk about contemplating the aliens and what we actually do. What's the scientific experiment to do this? The central question in this subject, in advance of finding intelligent life elsewhere, and with such an expectation of habitable worlds, is where are they? And Enrico Fermi asked this, a very well-posed question, back in 1950, because he knew that our civilization is so young, and a very small extrapolation of what we can do would have us traveling the galaxy. That's simply the fact. No new technologies are required. He also knew that there were an incredibly large number of sites for life and an incredibly long time. There could have been an Earth-like planet with an absolute Earth clone, as close as you could get, that formed 6 billion years before the Earth formed, and have that much of a head start on us in terms of evolution. What would that have spawned? There could be creatures out there that are to us as we are to anaerobic bacteria. What would that look like? These are the questions that we expect nature may have provided, and we can't answer these questions. And so the possible answers to Fermi are, of course, diverse, because we don't know the answer. It's possible they don't exist, and we are a unique accident as a technological intelligent species. It's possible they're rare enough that in time and space we're isolated. The universe is a big place. The galaxy is a big place. It's quite possible they're either unrecognizable or inscrutable, that we don't know they're there, we don't know how to recognize them. There are communications we don't know how to recognize even as communications. And it's another possibility is that they don't care. If we went to a distant planet and found some lichen on the surface of a rock and wrote it in our tricorder, lichen, not very interesting, they may be as advanced to us as we are to lichen. So they've already visited the Earth and just wrote, humans, uninteresting, move on. You know, I mean, that's not the science fiction trope, but that's possibly what happened. And then another possibility is that they actually created us. And I'm going to skip ahead a little here because I'm getting behind. So let me talk about how we might make contact. So this is the scientific experiment of SETI. This is not how it's going to happen. We're not going to tempt them with groceries or candy or beer or anything like that. It is possible that they're among us, which I guess logically also means among you or me. So that's a possibility that we don't need to look far because they're already here. But let me just discount that for a minute and say that with what we know at the moment, the way we approach the issue of technological civilizations and communication with intelligent aliens is by looking at the way the real estate of the Milky Way reduces when you ask that it have planets, that the planets be habitable, that life actually happens on those planets that are habitable, that there's sufficient time and the occurrence of intelligence, that intelligence gets technology, and you can see it's a diminishing set of terms which turns into the Drake equation. And so the Drake equation is a simple formula to calculate the number of intelligent communicable civilizations. And what you'll recognize is that the first three terms are astronomical. The first three terms are essentially measured by information I've given you this evening. The third, the fourth, fifth, and sixth, and seventh terms are indeterminate. We have no idea what they are, and so you can get any n you want, and that's just the state we're in at the moment. What have we done? We've sent little messages in a bottle. This was attached to the Pioneer 10 spacecraft, now left the solar system. This was attached to the Voyager spacecraft, now left the solar system, and you could critique it because we don't even use that technology on Earth. We're really showing them how clever we are, aren't we? Well, okay, I know there are audiophiles that do use this The scientists involved actually defended this because they said it's actually very robust analog technology. We don't know the longevity of DVDs or CDs. There's already signs they degrade. So this will last 100,000 years. Not a bad idea. So here's the real state of the experiment. If you know anything about the search for extraterrestrial intelligence, mostly using radio signals and not more recently using optical pulsed lasers, you'll know that we've had 50 years of silence. But the people who do this work are an indomitable species because they don't get discouraged by 50 years of failure. I think I would go away with my tail between my legs after probably a decade, but you know, there's some of them been plugging away for 50 years, like Frank Drake himself. But it's getting interesting because they are projecting that within a decade or so, we will have the capacity to listen to our analog technology of radio transmitters or pulsed lasers on any of 100 million stars at distances of up to 3,000 light years. That's pretty impressive. That means if any civilization on planets around any of 100 million stars are transmitting information by those two methods, we could detect it, and they could detect us. And I do think that makes an interesting scientific experiment, and they'll just point out that we've only just got into the regime where we have this capability. So it's a transient thing, you know, you're only going to detect civilizations that are somewhere near your stage of development because, you know, in 50 years we'll be making baby universes and slinging gravity waves at each other and we'll be doing other things. We're not going to be using lasers and radio transmitters. We'll do something else. A less comfortable possibility is that they are very advanced, and I've mentioned one possibility of them being very advanced is that they don't care. Another one sort of brings down our sense of ourselves because they might view us a slightly different way. And that's sort of the Stephen Hawking scenario where we sort of don't want to make contact because we don't want to know the answer. So to conclude, let me give you the census of habitable worlds. Let me give you the full real estate that's out there, and you can do the math in your head of what you think the likelihood of life on those planets is, because we don't know. So you can put in the number you like. So here's an analogy. Let's use grains of sand, because at least we can visualize this. The numbers are too large otherwise. The number of grains of sand you could put on your finger if you wet your fingertip, maybe 500. That's how many exoplanets we've found. That's how many stars nearby, really nearby, within tens of light years we've looked at since 1995. These are mostly the giant planets. The terrestrial planets are motes too small to see. We expect, based on the numbers I've given you and the Kepler results, 1 billion habitable worlds in the Milky Way galaxy alone. Probably 10% of those will be terrestrial Earth-like planets, not total Earth clones, but pretty close, spitting distance from Earth, 100 million. Then remember previous lectures, 100 billion galaxies in the observable universe. That means the number of habitable planets in the universe is the grains of sand on the entire arc of beach, miles long. That is a conservative, traditional habitable zone with liquid water on the surface using current statistics. That's what the universe has provided. Do you prefer that those billion habitable worlds are all sterile? The life happened on none of them? What fraction do you think it happened on? And assuming it happens on some fraction, what fraction of those do you think the experiment persists long enough for something interesting like this to happen? It's an interesting question. It's well motivated, well conceived, and we may actually start to get the answer. This travelogue is a snapshot of how difficult this experiment is. You're seeing an exoplanet, an imagined distant world, every 5 seconds. And we don't know what they look like. Most of them will be sterile. Most of them will be uninteresting. Most of them will be dead. In this travelogue, where one exoplanet is every 5 seconds, to just do a snapshot view of the truly Earth-like habitable worlds in the Milky Way alone would take 5,000 years. That's how much real estate there is. To do it in the universe, forget it. There's not enough geological time to do it. So this is the experiment that's underway. It's at the limit of our technologies. It's really hard to do. Finding Earths is going to be the challenge of the next decade, and we will find Earths. They won't be close, they won't be easy to follow up. Those traces of life will be hard to find. But I think the game is now on, and that's very exciting. And my last video clip I want to pay homage to as a hero of mine and a hero of many of my colleagues, actually, who conceived of most of these ideas, who laid out the landscape of astrobiology decades before planets around other stars were discovered. Carl Sagan.
I'm not very good at singing songs, but here's a try.
This is him updated a little.
If you wish to make an apple pie from scratch, you must first invent the universe. Space is filled with a network of wormholes. You might emerge somewhere else in space, somewhere else in time. The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. The cosmos is full beyond measure. Elegant truths of exquisite interrelationships of the awesome machinery of nature. I believe our future depends powerfully on how well we understand this cosmos, in which we float like a mote of dust in the morning sky. But the brain does much more than just recollect. It intercompares, it synthesizes, analyzes, it generates abstractions. The simplest thought, like the concept of the number one, has an elaborate logical underpinning. The brain has its own language for testing the structure and consistency of the world. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars.
For thousands of years, people have wondered about the universe. Did it stretch out forever, or was there a limit? From the Big Bang to black holes, from dark matter to a possible big crunch, our image of the universe today is full of strange sounding ideas.
How lucky we are to live in this time, the first moment in human history when we are, in fact, visiting other worlds. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. The surface of the Earth is the shore of a cosmic ocean. Recently, we've waded a little way up, and the water seems inviting.
Well, we thank you very much for coming. A big round of applause to Chris Impey.